Hey, how you doing? My name's Elton. Welcome to Learn Docker in a Month of Lunches. This is episode 19, and we are very close to the end. So if you've been sticking with the series so far, thank you. We've got some big topics to finish on, so hopefully you're going to find this really useful and just kind of round off your knowledge of what you've learned about containers and Docker in the last few weeks. So today's episode is all about reverse proxies. So it's a kind of scary sounding name of a technology. And it's been around for a long time, but in the container world, it's become a lot more front and center because you can run your reverse proxy in all your environments. It's a pretty crucial bit of infrastructure to have when you're working with containers. So we're going to see a couple of examples using some of the most popular reverse proxies that are out there, and it's not a scary topic. So whereas in the old days, it would have been something that maybe your production team dealt with, in the container world, you can bring that stuff right into your dev experience, and you can get like real benefits to having a reverse proxy to manage a whole bunch of kind of networky infrastructure concerns, but do all in containers with software configuration. Okay, so let's go and look at what we're looking at today. So it's episode 19. We're looking at chapter 20 of the book. As always, I'm going to roll through DIAMOL.net, which is the homepage for the book. That will tell you all the links to everything that you need to know about. So all the links to the episodes on YouTube, the links to buy the book, all that sort of stuff. A little bit about me in case you're interested in that. The focus is chapter 20, which is controlling HTTP traffic to containers with a reverse proxy. And we're going to be using two reverse proxies. A technology has been around for a very long time called Nginx, and a more modern technology called Traefik. They approach the problem, they solve the problem, similar sorts of problems, but in very different ways. There's some good examples of how you can choose between the two there. And as always, there's Q&A, so the YouTube chat is open, the Slack channel is open. I don't think I'm running Slack, so I need to start up my Slack in the background here. Anything you want to ask me during the show, put your stuff in there. I usually go on for 55-ish minutes. If there's something worth talking about at the end, I will pick it up at the end. Okay, so let's get on with the show. So we're going to switch over to my browser here. So this is diamol.net. This is the homepage for the book, Diamol, Docker in a Month of Lunches. Big news today. So I went and checked on Amazon, and I have got a review. So there's a 5-star review here, which is great. Thank you very much to James D. Bartlett III, if you're watching, James. He says that I definitely walk the fine line between breadth and brevity. You wait till you read the Kubernetes book, James, because that's a much harder line to walk when you're talking about Kubernetes. But thank you very much for the review. Hopefully lots more 5-star reviews will roll in. If you buy the book from Manning, they've usually got discounts and stuff. All the source code and all the Docker files, it's all up on GitHub. So don't feel like you have to buy the book. You can just watch the shows, get the source code on GitHub and follow along for yourself. And then here's the stuff about the stream. There's the Slack channel. I've usually got some codes to give away for free copies of the digital book. So go to the giveaway, put your email address in. You may or may not win a copy of the book. And when you're done with Docker, then my sequel book is called Learn Kubernetes in a Month of Lunches. Same format, a lot more content because there's a lot more to Kubernetes. Okay, and this is where we're coming to. So now we're on week 4, getting your containers ready for production. We've done optimizing your images, we've done config management, logging, and now we're doing the network side of it with reverse proxy. Okay, so let's go straight into that. So how long was that for? That's like 3 minutes of advert, or 2 minutes maybe. Okay, so here we go. So Docker, we know all about Traefik because we know that Docker has this. It abstracts the networking layer so that containers can talk to each other using the container name, which becomes the DNS name. There's a DNS server inside Docker, so that when you go in, when one component is looking for another component, so when my random number website looks for the numbers API component, it does the DNS lookup to find it, and Docker gives it the IP address of the container. That's fine. Docker also takes care of network traffic coming into the Docker engine or into the cluster if you're running in swarm mode. And so you can publish the ports on your container and then map them. So I can have port 80 on my container. When any traffic comes into port 8081 on my server, then Docker picks it up and it sends it into the container. Now, obviously, that's highly limited because you don't do that in production. So when we've been running examples in this in the book, what we've seen is sometimes we just run loads and loads of different random ports, like one exercise is 8081 and then 8082 and then 8083. Computer systems can only listen on one port. Only one thing can listen on a port, and that's true for containers as well. And this is where a reverse proxy comes in. So the reverse proxy is the component that receives all the traffic, and then it works out where to go and fetch the content from. So there's a tiny bit of theory to start with this, because I'm aware that not everyone's familiar with this kind of networking part of the view of the world. So a proxy is just something that sits in your network, and it handles traffic on behalf of something else. So in a corporate organization, you have a proxy sitting between you and the internet. So every time you go and make a connection and you go and look up diamol.net, then it goes through the proxy, and it can apply a whole bunch of rules. It can do caching so that, not everything comes from the outside world. It can store it locally to your organization. It can do all the scary stuff like tracking to see how long you're spending on things, and, authorizing whether you're allowed to go to certain websites, all that sort of stuff. That's an ordinary proxy. A reverse proxy is the opposite. A reverse proxy is what you run if you're receiving traffic from the outside world. And maybe you've got, like, the classic example is I've got several domain names, but they're all running on one server. So I run a reverse proxy on my server. All the traffic comes into the proxy, and it decides where to go and fetch the content from. And it's the same. That's how it works in the container world. So if we look at this diagram here, I've got a container running a reverse proxy. That's the only thing with a publish port. So I can publish port 80 and port 443. So all the traffic, all the ordinary HTTP traffic can flow into my reverse proxy. And then it will go and fetch the content as required. So whether the user's trying to browse to my to-do list or my image gallery or the random number application, it will know that from the incoming request, and it can go and fetch the traffic from the upstream component. That's what they call in the reverse proxy world. The thing that's actually hosting the content is the upstream. Now that's important because then those things don't have to listen on any port. So the only thing that's publicly available is my reverse proxy. It's good for several reasons, but one of the reasons is that you can centralize an awful lot of interesting logic into your reverse proxy. Okay, so let's get started here. So it's not all just theory. So the two things that I'm going to show you with are Nginx and Traefik. Nginx has been around for a long time. It's a really lightweight and super powerful web server. So if you look at the charts over time, like Nginx takes about a third of internet traffic. So, there with Microsoft IIS and Apache. So those are the big three, really. You can run it just to serve static content, just as an HTML web server, HTTP web server, but it can also be a reverse proxy. But we're going to see how it looks like just as a reverse proxy. So I've already run this before, so I guess this is going to fail because I've already got that network. All I'm doing is creating a network for my containers to talk to, so I can keep them separate from other parts of exercises that I've done. And I think I'm probably already in the right place. No, I'm not in the right place. That's cool. So I'm going to switch over to my exercises for today, for today's chapter. And I'm going to run Nginx. Again, there's some volume mounts here. There's some bind mounts. The format is different for Linux or Windows containers. So if you're running Windows, there's a slightly different command to run. You'll get the same output. So all that Docker Compose file is just defining my Nginx. I'll show you the Docker Compose file in a second, but just to confirm everything's up and running, if I look at localhost, and I'm using port 80 now, so the ordinary HTTP web server port, and that's what Nginx looks like when it's not hosting any content. If you just run Nginx, you can just do docker run Nginx, official image on Docker Hub. You'll get this. You won't get that, hopefully. Let's go and see what's going on there, because that's not great, because that didn't happen earlier. Let me do my Docker PS. The great thing about this is all the live debugging that you have to do. So Docker PS-A, what happened there? It died. Why did it die? Let's look at the logs. So you know things are going bad. Excuse me. When I use Docker PS instead of Docker Container LS and Docker logs, this means I'm trying to work out. Oh, that's why. Okay. Oh, I know. Right, hang on. Let me go and do this because I tried all the exercises before today. There's a lot of file monkeying goes on around here. So what I need to do, excuse me, is go into sites enabled and delete all these things. You won't have this issue when you pull the code because this won't have happened. Delete all those things. Okay, cool. Actually, that's great because I'll talk about that later in the chapter. So I'll explain why that happened in just a second. So let's get rid of this. And let's do this again. This is the bit I would edit out if it wasn't live. So I'm going to do my Docker Compose up. I'm going to just make sure that the thing is still running. So that looks good. Now let's refresh. Okay, this is what you get. So this is just Nginx. It's not configured to do anything else at the moment. The problem that I saw just then is that I still have some old configuration files lying around. So it was looking for an upstream component that it could fetch content from. And there weren't any because I'm not running any containers yet. But now that I've got rid of those, everything's hunky-dory. Okay, so this is the thing that we get into. So this is how you configure Nginx. Nginx has a config file for each website that it serves. Now, whether it's actually serving the content itself or whether it's going to fetch it from an upstream component, it's just this config file that defines what that looks like. So if I go and open up my browser, we'll show you what these things look like. The first one I'm going to do before I get ahead of myself is who am I? Okay, so this is the who am I one. So that Docker Compose file that I ran, All it does is it just runs my own version of Nginx. As always, I've got my golden images. My Nginx image is just the official Nginx image on Linux, but I've got my own version for Windows because there isn't a public one on Windows. And my override for Linux just binds these local sites-enabled files folders to my container. So when Nginx runs, it looks inside this sites-enabled folder, and that's all the sites that it's going to publish. So what I'm going to do is set it to publish a web application. And this is what the configuration looks like. So in the episode about Jenkins, one of the questions was, like, do we have to learn about Jenkins? And my answer was, well, kind of. There's so much more around Docker. There's so much more practices and techniques and tools that you're going to kind of want to be part of, not just kind of leave this to something else. And I'm sure there'll be a question of, do I have to learn all this stuff? Not necessarily. Further on in the episode, I'll be showing you Traefik, which has a very different way of doing configuration. But this is actually pretty super simple. So what it's saying is, when you make a request for the host name whoami.local, which I've got in my host file, then Nginx will apply this set of configuration. And the configuration is really simple. It's just going to pass everything on to a server called whoami, which will really be a container. So when Nginx gets this configuration, it's going to start up. It's going to make sure it can talk to that whoami container, and if not, it'll fail, which is what we saw earlier. And then it's just a couple of things to set the header. So the incoming request to my whoami container will have the host name set, and the return response will have this X host header, and we'll see all that in action. Okay, so let's close that down. Let's do these things in the proper order. So close this. If I go and look at my my host file, I've already done all the host file stuff. The host file is it's a local DNS lookup, really. So when I look up whoami.local, it'll just return my local IP address. There's all the exercises. You've got the commands that you need to run, but you need to be an admin. So I've already done all that stuff. This is how you do it on Linux, and this is how you do it on Windows. Okay, so when I browse to whoami.local from my machine, it's the same effect as browsing to localhost. But when I go through the browser, it will set that host name for the request, the HTTP request, will have a header saying that the host is equal to whoami.local, and that's the thing that Nginx picks up. So when Nginx gets that request on port 80, it says you're asking for whoami.local, and it will load it'll load that configuration for that site, and it'll go and fetch it from my whoami container. Okay, so let's go and run that whoami container. Nothing special in there. All that does is creates one container and plugs it into the same network as my Nginx container. And this is the bit that I'd left hanging around. If I copy my configuration file, that config file that I've just looked at that said when you get a request for whoami.local, you're going to get it from the whoami container. As soon as I copy that into that sites enabled folder, that's where Nginx is looking for its configuration, but it doesn't see the change. I've talked about hot reloads of config, where you can update the value of a config map in Kubernetes. You can update the content of a config object or change a file that you're using in a bind mount. It doesn't necessarily mean your application is going to reload its config. So some applications just load the config once from the file when they start, and they never look at that file again. Nginx is one of those. So if I want to reload the new config, I have to restart the container, and I can do that by running this command here to restart the Nginx container. So now it will see the new config, and it will be able to serve that whoami.local. So if I browse to whoami.local and then come over to here, that's going to hit that new sites enabled thing, and I get this response here. So this is coming from my container. It's just JSON that comes up, but it's just a text string. So I can refresh this as many times as I like, and Nginx when it's receiving the request, it's using the incoming host header to find out which site it should serve. And in this case, it's not got the content itself. It's fetching it from my whoami container. The whoami container is not publishing any ports. This is going into my Nginx, and behind the scenes, it's getting the content. Important thing to realize that the reverse proxy doesn't redirect the client. It doesn't tell the client to go to the whoami container. That all happens internally. So my whoami container doesn't publish any ports to be able to get to the outside world. So if I clear this down and just double check that, what you'll see here is my Nginx container is mapping port 80, and my whoami container is listing on port 80 inside the container, but it's not mapped. So only the Nginx container is talking to the whoami container. Okay, so let's clear this down. When we browse that, so Nginx got the request, it uses that host header, it finds the configuration, and it sends it back. Here's what the Nginx configuration looks like. Nginx is a hugely powerful tool, and your Nginx config files, if you're going to bulk this out and take advantage of all the features that it's got, will run to hundreds and hundreds of lines. But it's as simple as this. So if you just want to use it as a reverse proxy, this is all you need. You have one of these files for each of the sites that you want to serve, and that's the content they have. And that's really kind of about it. That X host thing there that you see, if I do a curl instead of looking at the browser, if I do whoami.local, what we'll see is, and if I do, I can remember the flag. There we are. So if I ask curl to give me all the information it's got, then in the response, my head's in the way, you can see this. This is the container ID of the whoami container. So all that whoami app does is it just tells you container ID and a bit of information about it. The response that comes from Nginx includes a host header, which gives you the container ID of Nginx. So I can see that they're coming from different containers. And that's not compulsory. It's just really helpful for debugging stuff when you're trying to find out what's going on with your proxies. Okay, so that's all that running. So we've seen how that looks. Reverse proxies, usually they work on an HTTP level, but it's not just for websites. Anything that's HTTP, so REST APIs. Nginx also does other types of traffic, so it can sit in the middle of just plain network traffic or gRPC, which is really useful if you're working with different protocols. But then the simple example I've used is Nginx is really just a pass-through. So it receives incoming requests, it loads the content, and then sends them back. But having that piece in the middle, right in the middle of your network infrastructure, you can load all your configuration in there, and it can be the center point for a whole bunch of interesting things. So I'm going to show this with another example now. So I'm going to load that random number app that we've seen before. And I'm going to run that again. This is going to be the upstream for my application. So I'm running my API. This is just the API part of it. I'm going to copy in another Nginx config file into that sites enabled folder, and I'm going to restart Nginx again. Okay, so let's restart that, and then I'll go over here and we'll check out that file. So this is api.numbers.local. It's exactly the same, right? So all that's changed is the host of the server that this represents. So this is the HTTP server and the name of the container to pass it on to. So I'm not doing anything different here. I've now got Nginx is able to proxy 2 different sites, and I can get to them using the hostname header. Again, I've added this api.numbers.local to my host to my host file. So I can go and browse to API, what do I call it? api.numbers.local, and I'll be able to see my random number. And this was the same application. If you remember, the API doesn't work properly all the time. I'm probably not looking at the right port. Let's go and check what I should be doing. So browse to HTTP. Yes, I need to /RNG. That's the bit you need. Okay, so if I browse to that RNG, which is the random number generator, I just get a random number back. And this is the API that fails after a little while. So when it fails, I get a 500 response. Nginx isn't doing anything clever for me. It's literally just every time I send a request to Nginx, it's fetching the content from the upstream and sending it back. If it's an error, it sends back the error. So it's not doing anything smart other than the fact that now I've got 2 sites with different URLs hosted from different containers listening on the same port. So Nginx is the thing that's listening on the port, and it's farming out the traffic. It's routing the traffic for me. Apologies if you speak American English. When I say routing, I think that's what you would call routing, but I can't say routing because it just sounds strange to my ears. So when I talk about routing, that's what I mean. Okay. So you see that Nginx isn't doing anything clever. It can do clever stuff, and we will see that as the episode goes on. But you can just get up and running and just use it as a routing component to get to other containers to start with. Okay, so the next thing you're going to do is you can do SSL, you can do caching, you can do sticky sessions, all that stuff, which lives in the proxy layer and just it becomes part of the proxy configuration, which is more or less hard depending on what you're trying to do. The next thing we'll look at here is this is the part that we saw right at the beginning. When Nginx starts, it reads all of the server configuration. So all of those sites enabled files, it reads them all up, and it makes sure that it can contact the upstream as just part of its kind of bootstrap checks. We talked earlier on in this series about doing a dependency check when your application starts. That's exactly what Nginx does. It says it's not part of the container setup. It's just part of how Nginx works. When the application runs, it reads all the config, it works out all the upstreams that it should be able to contact, and if it can't reach any of them, then it can't do its job, so it exits. So you get that unfortunate start to your episode. But all it's actually doing is it's querying the DNS server inside Docker and then getting a container IP address and making sure it can reach that container. So that's the first thing. We can do, because it's just going to be routing requests from an upstream, we can do load balancing in there. So I can run multiple component instances of my API server or my website in containers and have Nginx load balancing between them. Now, I can't do that without having to, I'd have to go to like Docker Swarm or something like that to be able to have several containers sharing the same port. But with Nginx in place, I can do it all with Nginx. So let's go and see how this looks. So again, I've got my image gallery.local. I've already added that to my path. This is how you would do it if you're running through the whole exercise. I'm going to start my image gallery with 3 instances of the web component. So I'm starting up my image gallery. Nothing new here with the Docker Compose stuff. We've seen all this in the series so far. A couple of episodes about Compose if you missed those. So I'm starting up my image gallery. My Docker Compose file doesn't do anything particularly clever. I'm just scaling up my image gallery to run 3 containers. So I've got 3 of those. That's the web part of the application. So now I'm going to take in an Nginx configuration. I'm going to copy that from my image gallery application. I'm going to restart Nginx. And we're going to look at that config file. So this is the first one, and again, let's close that down. It doesn't do anything interesting except, as before, this is the host name that it's looking for. So this is the key that gives Nginx this set of config to use. It's passing it on to my image gallery, but there are now 3 of those that live behind the same DNS name. And we talked about this also, that when you query DNS within Docker and there are multiple containers running, then Docker sends back all the IP addresses and it round robins them. So you do get load balancing, even though there's even if it's just with a single domain name. I'm adding that X proxy header so that I can see in the response the container ID of the proxy, but also I'm adding this X upstream header, which will tell me which container Nginx got the data from. So these are just like little helpful things that you probably won't put in production because it's giving away too much information. But in your non-prod environments, it's really helpful just to make sure that your proxy is doing what you think it should. So make sure the proxy is actually handling the response and make sure that it is load balancing the request. So that's all that configuration does. So rather than browse to the site right now, I'm just going to use curl. If you're a Windows user, curl is pre-installed in Windows 10 in all the most recent versions, but it's curl.exe. That's the full curl that you get with Linux and Mac OS as well. It's aliased by default to be a PowerShell command. So if you want to use the real curl, then what you can do is in your profile. Sorry if you're not a Windows user. You can just have an alias. So aliases in Windows working the same way as in Linux. You can remove that alias for curl, and then curl.exe will be the real one. Yeah, so that was a digression. Probably didn't help most of the audience. So this is using the real curl. The reason I mention that is because the flags are different for the real curl and the alias. So I'm going to my image gallery.local. So I get my response here. So I can see the response is coming from Nginx. That's the server. The proxy is the container ID of the Nginx proxy container. And the upstream is the address of the container that it used. So that's the internal container address. You can't get to that unless you're connected to my chapter 20 network and you're a container. So, but you wouldn't normally include that information. If I look at it again, then what we'll hopefully see, that time it was 0.09, this time it's 0.08. You see that with my head in the way? I need to go the other way. So it's being round robin between all my containers. So let's clear this down and do a couple more. So let's see how this. And if I curl, so this time it's 0.7, then it's 0.9 again. So by having because the Nginx container is going and fetching from DNS to find out the IP addresses, then all that load balancing happens. I don't need to have several containers listening on that port. If I want to see what my app looks like in a production like run configuration where I've got multiple containers, I want to make sure that my sessions work and everything works with load balancing. I don't need to spin up an orchestrator. I can just have that configuration and Nginx and make sure that will make sure that my load balancing happens. Okay, so that's the upstream bit that I've put in there. So this is the bit about I can switch to a production like config without having to run a whole bunch of other stuff. I can prove out that there are no issues when I'm running at scale on my local environment just with containers. Okay, so that's the output we've seen there. So the next thing is, so far I've just been, my configuration has been pretty simple. I've just used it to say, here's the site, here's the name of the host that you're listening from, and here's where you're going to get the content from. I'm not doing anything else, but you can do really kind of fine-grained matching of incoming paths to target upstreams. So if I go and look now, I'm going to remove my current image gallery configuration. So I'm going to delete that file. I'm going to copy in a new image gallery configuration, which does a few other things. makes the API part available, but on the same domain name. So, and let's go and start that up. So I'm going to restart Nginx. All my other containers are already running. I'm going to go and check out the configuration before we go any further. So this is image gallery 2. So the first part is still the same. My image gallery.local is the host name that Nginx is listening for. When it gets a request for /, which is the home page for the website, it's going to go to the website and it will be round robined, and I can see my upstream stuff in there. When it gets a request for /API/image, then it's going to go to the API container, so a completely different container. So what I'm doing here is I'm presenting under a single domain name. I'm building up the feature set of my application, so I can browse to the website. I can tell people to go to the API path, and they'll get an API response. But they're actually coming from completely different containers. So my proxy is putting this facade over a whole bunch of separate components. So it looks like they're all part of the same domain, but actually they're being served internally by different components. So let's go and just prove that does work. So now I can browse to http imagegallery.local /API/image, and I get my JSON response back. So this is the API component that previously, if I wanted to look at the content of that and have the website running, they'd have to be on different ports. But now they're going through Nginx. I'm using my local host name, and I've just added that new path in there, so I can see the content of the API, and it looks as if it's part of the image gallery web application, even though it's actually coming from a completely different container, a completely different technology stack. Okay, so this is how that looks. We saw that stuff there. So what I talk about, these kind of infrastructure level concerns, these are the things that you would previously have been well over in the kind of ops domain and the production domain. How do we worry about load balancing? How do we configure the routing and the paths and all that sort of stuff? And the next thing that comes in there is SSL. So ordinarily, all your production sites are going to be HTTPS. In order to get HTTPS, you need a certificate that identifies the website and comes from a trusted authority and all that sort of stuff. And those are confidential bits of data that need to be stored somewhere and managed so that no one can grab your cert and spoof your site. Nginx, you can configure real certificates and get your certificate from Let's Encrypt or whoever you're using to mint your certificates, or you can just generate your own. So when you generate your own certificates, they're only any good for non-production environments because all the browsers will throw up this massive warning and refuse to connect. But that's fine if you're a dev and you want to just make sure that everything works when you turn the security on. You don't get any sort of strange behavior, and that's what we can do. We can do that in the proxy too. So you're going to load up the proxy with all of your SSL certs, which might come from secrets from the platform when you're running in production, and then as part of each site's configuration, you'll say for this site, here's the cert you use, and for this site, you can use a different cert. Okay, so let's go and see how that looks. So the stuff about generating a cert, I'm not going to go into. I've already wrapped it up in a container for you. So you just need to run this container, and it's going to generate a self-signed certificate. There'll be a whole bunch of interesting looking output that comes in here, and it generates a whole bunch of these key and certificate files, which are the things that contain the actual certificate that gets given to browsers when they come and connect to the site, and the private key that stays on the server that it uses to encrypt the communication. Okay, so now I've got this, I've created this self-signed certificate for that host name, for imagegallery.local. So I can get rid of my current configuration. And again, this is all happening within Nginx. I'm not changing my application code at all, or my application configuration at all. And I'm copying this version 3 configuration, restarting Nginx. You're getting a feel for the pattern now. And now, if I go and check out that version 3, there's a whole ton of more stuff in here. So when you start looking at SSL, there's a lot of fine tuning that you do to make sure that your site is as secure as it can be. And this stuff changes all the time as well. There's a really good website called sslabs.com, which I referenced in the chapter, and you give it the address of your website, and it gives you a grading from like A+ down to something that you don't want to be going down to tell you how secure you are. And it tells you, you can work out all the things you need to do. So all these little bits and pieces about the ciphers and the protocols, that's just fairly standard stuff. And Nginx lets you configure that using these config files in the same way that every web server lets you configure it in some way or another. But the important thing bit is here, which is my SSL certificate. So all I've done is I've generated this cert. I've put it in the folder, which is bind mounted into my container. So in production, that would come from a secret. And I'm saying that this is for my imagegallery.local, and it's listening on port 443. So when I run Nginx, it's bound to 2 ports, 80 and 443, so I can browse to it for HTTPS traffic too. So there's a whole bunch of other stuff here which is to do with the SSL configuration, but then ultimately within that, my locations haven't changed. So my web application and my API net, they're now secured with HTTPS. And right at the top here, if I go and look here, I've got another server for imagegallery.local listening on port 80. So this is when I come in, when a browser comes in on HTTP, they're going to get redirected to the HTTPS version. So Nginx will take care of that too. So that does go back to the client and says, you need to come back on HTTPS, and then it will hit this block instead, and you'll get the secure response. And that's all in your Nginx configuration. Nginx is not an unusual technology. So if you're starting to look at these config files and thinking, well, there's just tons of stuff here, it's incredibly well documented. People have been using it and tuning it for years. So you're not going to be kind of in a poorly trodden path when you start using Nginx. Okay, so now if I browse to HTTP imagegallery.local, behind the scenes, my browser will get a 301 response, and it will automatically redirect to the HTTPS, which you can see there. I get this big ugly warning telling me there's a security risk ahead. If I go and look and see what my security risk is, it says it's an unknown issuer. So it doesn't know. It is secure. There is an SSL certificate in there, but it's from someone that we don't know. It's not a trusted issuer. If I look at the certificate, we'll see it's my DIAMOL organization, and it's good for this DNS name. So that's why the browser is telling me that I'm not going to let you go there. But if you accept the risk, which you would do in dev, then you get your Enceladus in infrared, which is some of that stuff's quite scary. Okay, so South Pole obviously much hotter. So let's go back to the application, to the chapter here. So there's a lot of stuff in that exercise. Generating the certificate, there's a tool called OpenSSL, which is, if you go and look at self-signed certs if you go and Google for that, everything will tell you about OpenSSL. There's a script inside the container image. It's all part of the Docker files that are up on GitHub. You can see how this cert generator application works if you want to. All it does is it generates a certificate authority and then uses that to generate a certificate, and then it spits out all the certificate files at the end. So it's kind of generic. You can use it for any host name, and you can kind of generate your own certs for that. But they're only ever any good for non-production environments. Okay, so like I did, I clicked that advanced button and I went and I looked at the site. And this is that sslabs.com. If you're not sure what your own domain, how well your own domains are faring, you should go and look at that, because it will tell you if you score below A+ or A++, whatever is the maximum, it will tell you the things you need to do. So that's a good thing to have. And these are the main parts here. So that it's just picking up those certificates from a volume that gets mounted into the container. So it lives in the container file system, but obviously it could come from somewhere else. It could come from a secret in my platform. Okay, so now I'm using my reverse proxy to host multiple domains, to do routing for my API, and to do load balancing, and to do SSL. And it's all just going into those config files. The only complexity there is the SSL part, which is just inherently complex anyway. But the last thing we'll look at is a really big benefit for lots of websites, which is caching. So if you think all my client requests from the outside world are hitting my Nginx component, which is a super fast web server in its own right, and it's going off to my application components to go and fetch the content. Well, if that content doesn't change between 1,000 separate requests, then the proxy might as well cache it, because it can cache the response in memory, and it uses disk as well. And whichever it uses, the more popularly fetched requests end up in memory. It's bound to be faster than going to my application container, and that's good in two ways, because it means that the response time is faster, but also it reduces the traffic to my application containers. So anything that's static, there's no point in that going to your Go runtime or your Java runtime or your .NET runtime. There's no need to use those things to host static content. So you just configure your Nginx so that when it sees things that it decides that you can configure as being static content, it caches them, which means that the only requests that make it to your application containers are the things that it needs to process. So you're using the right component for the right job. So we'll see how that works here. So little diagram here to try and make that clear. Everything's coming to my reverse proxy as usual. The first thing it's going to do is to check its own local cache to see whether it's got that response. So, if you imagine my request has got a path and a bunch of other things, it will use that as the key for the cache. If it's got a response in there, it just goes straight back out. It never touches the upstream. If it doesn't have the response in the cache, it will go to the upstream and it will add it to the cache on the way back. So the next request that comes in that exactly matches will get the response from the cache. Now, obviously, you can't do that for every path of your application because some things will be user specific. So the way you build up your caching rules, you'd omit anything that's got some sort of cookie in there or some way of identifying a session. So the only thing you're caching is the static stuff, which is generic to everybody. Okay, so talked about that. Yeah, absolutely. So my image gallery app is completely generic and completely static, so that can be served by everybody. If you're thinking like a shop application, a shop website, then all of the catalog browsing stuff is potentially cacheable, and it's only things like the cart and the checkout process which you obviously wouldn't want to cache. Okay, so let's open up my terminal again. Let's remove the current configuration that we've got. That's got my SSL stuff and the load balancing and the routing stuff in there. I'm going to copy in a new configuration. This is my version 4. And I'm going to restart Nginx again. And that's going to pick up the latest config. I'm going to go and browse to my website here. So the new configuration has got a couple of other things in there. I'll show you in a second. It's got this. It's got the caching enabled, but it also adds a new header, so I know whether the cache worked or not. So this x-cache, in HTTP terms, there's a whole bunch of standard headers that go request headers and response headers. And if you add something non-standard, the convention is to prefix it with an X. So this X cache means it's kind of for my benefit. So that was a miss, which means that it went to the upstream, and it tells me the upstream that it went to. If I repeat that, I'm going to get my head in the way again there. So let me clear this down. I'll repeat it again. This time the X cache was a hit, and there is no upstream. So it doesn't touch the upstream. It fetched it from its cache. It knows it fetched it from the cache, and it populated that header, and it didn't go anywhere near my upstream. So now, if my upstream is able to handle 100 requests per second, and my Nginx container can handle 1,000 requests per second, which a single container can easily do, then I'm spreading the load around a lot more effectively. If we go and look at that config file, this was number 4. Close that down again. So all these things are incremental. So it's got the HTTP redirect. It's got all the SSL stuff. It's got some other bits in here. So I'm doing gzip. So if my application doesn't send out compressed responses, which it might not, like every browser since 1994 has been able to handle a compressed gzip response, and Nginx will do all that for me. So whether the response came from the cache or not, it can zip it on the way out, save a bunch of network network bandwidth. And then way down here, where's my caching stuff here? So down here, I've got 2 types of caching defined. So the proxy hash hasn't changed, so it's going to my image gallery component. I'm using a cache that's defined inside my Nginx image configuration. I've got 2 caches, long and short. And I'm saying that this cache is valid for 6 hours, as long as there's a 200 response that comes back from the upstream. So, as soon as I get a 200 response back from the upstream, this response will live in the cache. It's valid for 6 hours. And I will use that cache even if there's a problem with the upstream. So this caching is not just a performance thing, it's also a resilience thing. So if I have a temporary fault with my application container, Nginx, so even if my cache is stale, so 7 hours have gone by, another request comes in, my cache is stale, it goes to talk to my image gallery container and it can't find it, the container's down, it will serve up the stale cache. So imagine my website, I'm happy for it to be stale. My API, I'm using the short cache and it's only valid for 1 minute, and it's not valid if the container is not available. So 1 minute doesn't sound like much, but if you're dealing with 2,000 requests per second, then a cache of 1 minute saves you an awful lot of processing time. So this is the sort of thing that's really useful when you get to bigger scales. Okay, so if I go and look at this now, let's close this down. So the way with curl, I can put in this insecure flag, which says curl also knows that it's not a valid HTTPS certificate. It's not trusted. But if you say insecure, it will go ahead and it'll show it. So I go to my image gallery.local and I get a cache hit, so that looks good. And again, if I go and look at it again, clear this down, and I've got my cache hit, so that's all coming through. So it's not going to the upstream container at all. It's all still coming from the cache. So when you don't, you'll see the upstream business coming in through there. This is the reverse proxy, but this is the caching reverse proxy. So the things we've just talked about, it's really just down to these proxy cache configurations. And again, if it's new to you, it's not new to the rest of the world. So you can search for Nginx proxy underscore cache, and you will see a whole bunch of articles telling you the best practices for this. So those actual caches are just defined in my Nginx image. The definition of a cache just says how much space it should use, how much should be in memory, how much should be in disk, how long it should last, that sort of thing. That's a bit too technical even for this episode, but it's all there in the resources if you want to go and look at what's on GitHub. Okay, so let's have a look at how this works. So if I call this again, just to prove that everything is still coming from the cache. So that's, if I go and browse to my site, this is my image gallery.local. I'm viewing the whole thing here, so I'm not just looking at the headers. So I'm warming up the cache to make sure everything's in there. I'll do the same with my API. So everything's coming through, so that's all looking good. If I now go and kill those containers, so I'm getting rid of all the containers that have the name image gallery. I don't know why I don't use the docker compose command for this, but there we are. I'm getting rid of all of my web containers. And now if I try and curl it again, so if I just docker ps this, so you can see I've got, you probably can't see, I've got my access log, which is the component that logs IP addresses. I've got my API. I don't have any of the web containers, so there's nothing running. If I browse to it again, I'm just looking at the headers here. I get a 200 OK response, and I get an Xcache hit. So it's coming from the cache, even though the upstream is not available anymore. So I've added this layer of resilience around. Now, if I remove the API container, I should have done this first. No, that's not what I wanted to do. So I'm going to remove the API container. So now there's no API container either. If I clear this down, if I go and try the API again, now remember the cache was only valid for a minute, so I'm still getting a response from the cache here. Now, if I talk for long enough, then it'll go beyond the point where the cache is valid, and there is no use stale setting. So I don't have resilience built into the API. So that's a design decision that you make. For my website, I can live with the responses being stale. For my API, maybe that has to be either completely valid to the last minute, or I'd rather get an error and know that there was something wrong. So I don't know if that's enough talking. Let me have a look. Yes, okay, so now what's happening here, there's a delay because Nginx is trying to find that upstream and it has a connection timeout of whatever, 10 seconds, 30 seconds. So it's trying to get to my API container because I've told it not to use the cache if it's stale. So it's got an item in cache, it's expired, it's going to go back to my main site and it'll throw me an error. And you get this, you'll get used to this error, 502 bad gateway. If you see that on the web, it means that someone's got Nginx or something else configured and the upstream doesn't exist anymore. That's what that error is telling me. So I don't get the resilience from my API because of the way I've configured it. Those are all choices that I can make. Okay, so that's the output for that one. So that's all looking good. That's all for Nginx because that's quite a lot in that short amount of time. We did SSL, we did caching, we did load balancing, we did routing, and we did multiple domains in a single proxy. So those are the kind of the main infrastructure concerns that suddenly come into the world of containers that live in your configuration with your app alongside the rest of your source code. So it comes away from whatever process used to happen after your delivery went over to the production team to deploy it, and they applied their proxy settings. It all comes in right at the beginning, so everyone's running that same setup. The problem that we've got with Nginx is that it's not a new technology. It's not container native. It's been around for years and years and years. So it really just works at the network level and the config file level. So we've seen there's the workflow to publish a new site or to publish a change is I make that config change, and then I restart the container. You can actually tell Nginx to restart itself, but I'd have to connect to the container and restart the Nginx process or tell it to look again at its config. It doesn't do a hot dynamic reload for you, so you have to instruct it in some way to reload itself. The alternative we're going to look at is a container-aware reverse proxy. So I'm going to be using something called Traefik, which is an approximate pronunciation. It's a German company who make it, and I asked them how to pronounce it, whether it was Traefik or Traefik, and they said it's Traefik, but not quite. So I'm just going to keep saying Traefik. What Traefik does is it's container aware. It still solves the same sorts of problems that we've looked at. So that load balancing, that routing, that SSL termination. It does the same sort of thing, but it does it in a very different way. Instead of having a static configuration file that you have to manage, it plugs into the container platform and it queries your containers and it looks for labels on the containers and it builds up its own routing configuration based on how you label your containers. So you still you opt in to being proxied with your components, and you put these labels, just key value pairs, to tell it to metadata around your container, and then Traefik goes and looks at the Docker API, finds out new containers, and then builds its own routing rules, which is a lot less complicated than it sounds. So we did it also in chapter 11, which would have been episode 10, when we used Jenkins. We started Jenkins with a connection to the Docker API, where it was running, so that it could do Docker image build commands and run on the engine. Similarly with Traefik, we're going to mount the socket or the name pipe where Docker is running, but not to build images, but to query the API. So Docker has this streaming API that publishes events to say, here's a new container, or that container died, or whatever, and that will contain the labels, and then Traefik will use that to work itself out. Okay, so let's go and start this up. So I'm going to get rid of all of my containers. Let's clear this down. So I'm going to start with a completely clean slate. There's nothing that I've done except that I've got all those domain names in my host file. So I've gone back to kind of a clean slate. I'm going to start Traefik. Let's go and start this off. And again, because it does this bind mount to the Docker API, it's going to be different on Linux and Windows. If I go and show you what it looks like inside here. Let's get rid of that terminal for a second. So the Traefik, again, I've got my own version. Actually, this is a really good example of a multi-arc image up on Docker Hub. So I think the Traefik image is already Windows, Linux, ARM, and Intel. I'm passing a whole bunch of commands, which is just configuration settings, telling it basically that I want to look on port 80 and 443. This is the network to connect to, which is my chapter 20 network that I'm using. And actually, I'm mapping those ports in the command as well. And the only thing that's happening in the override is not that one. The override for Traefik is the volume, which is the bind mount for the Docker API. So in Linux, it's the Docker socket, and in Windows, it's going to be the name pipe. So that's the only thing that's different. Other than that, it's this multi-arc image that works in the same way on both. So there we go. So now I'm going to browse to port 8080. So I've mapped ports 80 and 443. So Traefik will be my web server for HTTP and HTTPS, but it also has its own little admin UI. So I can probably clear down some of these things. So I'm going to browse to 8080, and this is the Traefik UI. So again, you wouldn't make this publicly available, but it's there for when you're working in your non-prod environment. And it has this concept of there are three things that you configure. There's a router, which defines the rules. There are services, which are the upstreams, and there are middlewares, which can impact the pipeline between the incoming request and the upstream service. So just terminology that the Traefik uses. I'll go into a little bit more detail here. Okay, so that's what it looks like. We've just seen that, so everything works, so that's good. So so these are the main things. There's this idea of an entry point, and that's where Traefik is listening for incoming traffic. So that's where it's expecting to find the incoming requests. The routers are the set of rules that identify a target upstream. So rules like, we've used host name so far, and also for Nginx we had we built up a path for the API container, and we can do similar sorts of things in Traefik, but with different ways of configuring it. And then the services, they're the actual upstreams, so they're my containers. And then middleware lets you do all sorts of interesting things to modify the request before it gets to the upstream, or to modify the response before it goes back to the client. Okay, sounds complicated, but just so when you look at that dashboard and you think, what are all these pieces? That gives you a very high-level overview of what those pieces are like. Again, Traefik is not an unusual piece of technology. So people who are using reverse proxies in the container world, like Traefik is one of the ones that's pretty familiar. So it's not like you're going to be. I'm not recommending technologies that are very obscure here. This is a well-known bit of kit. Okay, so I'm going to deploy my Who Am I application again. So we're going to look at the same set of apps again with Traefik to show that we can kind of solve the same sort of problems. So I'm going to run my Who Am I app. I'm going to browse to Traefik to see that it's found it. So over here, back to my dashboard. So this is just to save me having to click around. So it knows the entry points. So all these entry points here for 8080, which is just for the dashboard, but for the website and for the secure website, potentially could receive traffic that's going to go onto this router, which is Who Am I at Docker. So it knows it can integrate actually with different types of upstream, and the service is going to be Who Am I. And then the router details down here, it's just got my rule in there is my host name, whoami.local, and it's going to go up to my Who Am I service, which is my web container. If I go and look at the HTTP services, there's Who Am I, which it knows is a Docker container, and that's the IP address of the container. Okay, so it found that without me having to do anything. I didn't configure Traefik or restart the container or anything like that. And the way it does that, get rid of this and do this. I'm going to go and look at my Who Am I for Traefik. And so it's the same Docker Compose file that just runs that who am I container application that just tells you the container ID. And I've got a Traefik override that just applies a bunch of labels. So it's like an opt-in mechanism. So I have a label to say Traefik.enable equals true, which means it's going to get added to the routing rules. The proxy will deal with this. And then the routing rule, so http.routers. So it's listening on the HTTP endpoint. So I don't have security for this one. The router is for the who am I component, and the rule is that host. So it's a slightly kind of a concise way of expressing how those rules work, but it works really neatly because it lets Traefik just use simple key value pairs, and exactly the same syntax. If I was to use this in Docker Swarm, you can use exactly the same approach in Kubernetes, but Kubernetes has a slightly different way of managing incoming traffic, which you'll have to wait a few months to find out about, if you want to find out about it from me, that is. Okay, so let's close this down and go back to here. So it should all still be working as expected, but now I'm going through a completely different proxy. So that's the other great thing about this. This is effectively a kind of a swap-in component. They're effectively commodity components, and you can use whichever one works for you. So I'm still using that same domain name. I get the same response back, but this time it's come from Traefik. Traefik doesn't impose its own server name. So when all the responses from Nginx told me they came from Nginx, Traefik gives you the originating server name. This is a .NET Core application, and the internal web service called Kestrel. So it tells me that it's coming back through Kestrel. Okay, and then that's the same thing as before. This is the actual content that came from the application. So it works just like before, but I didn't have to have a static config file. I just have these labels that I apply, and then Traefik builds up its own set of rules. Okay, so let's clear this down. So way down here, we're going to now move on to do some of the other apps to show you kind of how all these things fit together in the same sort of way. So again, for the image gallery app, I'm just going to put in my override file. And they're only override files because of the structure of the exercise. They would be in your ordinary compose file normally. So we're going, while that's starting up, we're going to look at that again. So this is my image gallery. And my override for Traefik. Again, it's the same set of labels, but there's just more of them. So I've got my, for the image gallery, which is the web application. So again, I'm opting in to receive, for Traefik to manage the content for this one. It's HTTP only because I've got my HTTP router set up. For the image gallery, the host is imagegallery.local. And then the load balancer server port tells it that there are multiple instances of the container running. So it's going to make sure that it uses them all. And then for the API, I'm making it look like the same thing. So the same URL will work that I built up in Nginx. So I'm using a router. The host is imagegallery.local, and the path prefix is API. And then this clunky bit here strips out that path prefix, which sounds more complicated than it is. So basically my Go application, my Java application, which is the API, doesn't have a path that starts with /API. You just go and get the image. So it's just /image. I want to publish that at an API part in my path. So I want to listen on /API/image. So what Traefik does is it's mapping the router to listen for /API/image, but then it's going to go to the container at /image. So I'm listening on one prefix, and I'm stripping that prefix out before I go onto my upstream component. Okay, so now it should all just work in the same way. So if I go and look at my image gallery, I get my response back in the same way. And if I go and look at the API, same URL, but completely different proxy that's configured in a completely different way. Let's go and look at my API image. I get the response back in the same way. So, like I said, they solve the same problems fundamentally, but they do it in a very different way. Depending on what you're trying to achieve, like Traefik is much cleaner, and you don't have to worry about managing that config file because those config files kind of get out of hand pretty fast. But then, arguably, the labels on your container objects get out of hand pretty fast as well. But in exchange for however you configure it with a bunch of labels or with a config file, you get a huge amount of features for very little input, really. Okay, so we can see I get my correct response, all that stuff there. They're not all reverse proxies are the same. So the two I talk about, Nginx and Traefik, they're not the full set. So there's also HA proxy. There's a whole bunch of other things that you can use. These are the two I would shortlist if you're just going to look at a couple of them. They don't all have the same feature set. So as of now, Traefik doesn't have caching support, which Nginx does. So you can't do that caching, but of course you could have multiple layers of proxies if you wanted to. SSL, Traefik has much better SSL support than Nginx. So with Nginx, you kind of have to give it your certificates. It only really works on the level of, you're securing this with HTTPS, and here are the certs. Whereas Traefik is able to go and talk to certificate providers. So you can configure it so that Traefik will go to Let's Encrypt. It will get a short-term certificate for you, 3 months or whatever. It will manage all that stuff for you, so you don't have to worry about that. And it comes with its own default self-signed provider. So you don't even have to create a self-signed cert for your non-production environments. So that's exactly what I'll do here. I'm going to run my image gallery again with a slightly different setup. Again, I'm not changing Traefik here because of the way it works. As soon as I deploy these changes to my containers, Docker is publishing those events on its API, which Traefik is listening to, and it's rebuilding its routing rule. So this routing rule is always up to date. So there's never really a lag between something going live and the routing rule. So I don't have to reactively apply my configuration. So let's go and check this override. Let's cut that down. So there's a lot more stuff in here now. So what I've got here is an extension of what I previously had. So I've still got some of those HTTP rules in there. But what I'm doing here is for my HTTP rule, there's a middleware there that redirects it to HTTPS. So just like in Nginx, I had a block for my HTTP server that redirected to my SSL server, which was a much bigger block. This is how that looks in Traefik. So I'm saying I am listening for HTTP, but all I'm doing is using the middleware to send it to HTTPS. And then I'm also listening on HTTPS, which is down here. So my HTTP router uses the secure endpoint. It's got TLS. And then I'm doing this other bit here to strip the prefix. So I'm just saying I'm kind of enrolling into a SSL, and I'm doing that redirect from HTTP to HTTPS. Same setup in my image gallery. So I'm opting into Traefik. I've got my host defined there. I've got my middleware to redirect from HTTP to HTTPS. And then here is my secure endpoint that's going to go to my web container. Okay, so there's a bunch of stuff in there again, but like I say, this is Traefik's documentation actually is exceptionally good. So go to their homepage, traefik.io, and their docs are really, really good. Okay, so let's check everything works. So let's open up my terminal again, clear that down. So this is going to my image gallery. I'm just getting the headers, so I'm not looking at the content for that one. For my API, I'm going to HTTPS, and I get everything back. So I've upgraded to an insecure. I could browse to my image gallery.local. I would get a similar warning, but from a different certificate issuer that's still untrusted. And I'm still getting the content back. So I've applied HTTPS with admittedly some rather cryptic labeling that I have to put on my components, but I didn't have to generate a certificate. I didn't have to write in all those weird SSL ciphers. All that stuff's taken care of for me by Traefik. And if I want to get Traefik to get me a real certificate, I just have to put in my Let's Encrypt details so it knows how to go and validate itself, and it would keep my certs up to date for me. Okay, how are we doing? We're getting quite close to time. Okay, so you need to decide what feature set you want, and then kind of look at these things. So they all do routing and load balancing and SSL termination. Nginx has caching, which Traefik doesn't have, but Traefik does sticky sessions, which is something that you get, Nginx does it, but it's kind of complicated. Even more complicated than the SSL stuff. With Traefik, sticky sessions is really easy. Now, sticky sessions are where typically in older applications, certain parts of the app weren't stateless. So, I would expect once I'm a user and I've put something in my checkout, then I always need to go back to the same server because the contents of my checkout are held in memory on that server. My session lives in the context of a particular server. When you move to a more modern architecture, you try and avoid that, and you store your session state somewhere centrally, so any number of servers or containers can receive that request. Doesn't matter which one gets it; they can all load the session from this kind of shared state. But when you're moving older apps to containers, they may depend on sticky sessions, and this comes up over and over again. Traefik makes it really easy. So what Traefik does, it kind of behaves in the same way as a typical sticky session would do. If you enroll with the rules to say that I want Traefik to handle my request, and you configure it for sticky sessions, it will make sure that the request from the same end user goes back to the same container. So even though the end user knows nothing about containers, they're browsing to a website which is handled by the proxy. The proxy sees a cookie telling it which container to use, and it will use that container. So Traefik makes that really, really super easy. So we'll just see how that looks here. So first of all, I'm going to scale up my Who Am I application to 3 containers. And so not sticky sessions yet. Everything's just running without sticky sessions. If I go and do curl, this dash C and dash B, you can tell curl to store a cookie file and reload a cookie file, and that's all that is doing. So I'm saying go to this website and use the cookies. So browsers do all that obviously automatically, but this is a way to automate it. So I'm getting a different one each time. That was 036. This is 519. If I look again, I get 657. So my requests are being load balanced. Even though I'm passing in my cookies, the site doesn't do anything like that, and nor does Traefik at the moment. So if I now deploy the sticky version, and then we'll see how it works, we'll just check out the configuration at the end. So I'm deploying the override to give it the sticky session capability. So it's going to recreate all those containers. Labels are part of the container environment, just like environment variables and the file system. So if you change a label, it's a new container. I've said several times you need to get used to the idea that replacing a container with a new one is a common thing that you're going to do all the time. So your apps need to be able to handle that. Okay, I'll do the same thing again. If I do a curl with my cookie file, I get 8fd is the container that sends it back. And if I try again, I get 8fd. And if I try again, I'll get 8fd. So I've got a sticky session, even though there are 3 containers that Traefik knows about, and it will load balance between them. I've told it to use sticky sessions. It will always go back to the same one. So if I go and check that sticky override, which is part of the Who Am I app, and close that down, and close that down so we can see it all. Again, it's just a whole bunch of labels. So I'm enabling Traefik. I'm just using HTTP, so I don't have all that extra SSL stuff. It's listening on that route. And that's it. Sticky equals true. And then I can tell it which cookie to use, the name of the cookie to use, and say that the cookie is only valid for HTTP. So there are certain niceties around using cookies that you need to be aware of. But that's all it does. And then suddenly I've got a sticky session, which is quite a tricky problem when I've got the outside world here and containers here, and they know nothing about the internal IP addresses of the containers. If I show you what that cookie file looks like, so this is the cookie file that curl is using. This is the cookie that comes back from so you can actually see this. Make this bigger again. This is the cookie which Traefik sets. So my Who Am I cookie, which is the thing that I named in my configuration, and it's got the actual IP address of my container, which is kind of unimportant really as far as the outside world is concerned, because you can't get to that from the outside world. You have to be connected not only to my container engine, but you have to be in the same container network to make any sense of that. So that's how Traefik uses a fairly simple mechanism actually to get what is quite a difficult problem solved. And then the only thing here is you need to be aware of, so that solves that problem of someone saying we want to move our app to containers, but we need sticky sessions. Well, this is one way you can do that fairly easily. But remember, containers are a lot more volatile than virtual machines, so a sticky session might not have the same impact, because your containers will be replaced a lot more frequently. So you need to bear that in mind. It won't crash your application. So if Traefik receives a request with a cookie in it saying go to this particular container, and that container's not there anymore, it'll just pick another one, and then it will set that session back. But that might mean your user loses their session if you do an upgrade and lose your container. Okay, we're going over time today, which is good because there's just so much content. But we're coming to the end. So this is the wrap up bit here. So there's a couple of patterns that make it where a reverse proxy really fits nicely. The first one is the most simple, which is what reverse proxies did in the old days, which is just one component that can host multiple domains. So a single thing listens on port 80 and 443. I've got all these different domain names, and it is just routing for them. So none of the complexity around SSL or anything like that. You could just do simple routing. The next one is microservices. So the idea that my proxy is handling effectively one domain name and presenting my application as a single coherent domain with a set of different paths, but each of those paths actually is coming from different components, and I can kind of selectively publish them through the proxy. So in this case, maybe I've got my website and one API that's available, but the other APIs are internal components that only the website uses. But if I decide I want to make something public, I just change my routing rules in my proxy. I don't need to go and make some whole new domain available or anything like that. And the third one, which is really a variation of the other ones, is if you're moving monolithic applications to containers. So people who have got a large legacy code base, they've often got these big kind of apps that are just one physical component. So everything goes in this one container, and they want to be able to break it down and make it more microservice-y, but they don't want to spend 2 years doing it. This is a nice way of being able to do that. Your proxy becomes a facade. So maybe I've got in this example, I'm using it for a new feature. So I've got a new path in there that comes to a new container. Completely different technology stacks, can be much more microservicey, but also I might have a path in there to overwrite something that was in the monolith. So I can gradually replace features as I'm working on them and move to a more distributed architecture, but by routing the rules inside the proxy without having to do a big old rewrite. Okay, and I think that's coming to the end now. So we've got the lab. You know how this lab stuff works. There's a new application which I also use in the Kubernetes book, which calculates pi for you. It's quite a handy application if you need pi to 50,000 decimal places. What the lab gets you to do is add caching there, and you will see a massive difference because it's something that's very compute heavy. So you'll see the response really easily when you've added caching in there. Okay, cool. So how are we doing on the questions here? So Iman says, I just got the book on Monday. Good for you, Iman. I'm going to look at the older videos. I should be able to follow everything. Yeah, absolutely. So so you can start in sequence. Each chapter is a kind of dedicated topic. Some of the chapters kind of build on previous ones in terms of the concepts, but each set of exercises is unique to the chapter. So you can follow along with chapter 20 and then go right back to chapter 2 if you want to, and you're not going to miss out. You can kind of skip around. The structure of the book, the structure of the episodes is one that I found works for people who are learning and are new to this space. But actually, if you know bits of it and you just want to pull in and out, then each chapter should be a kind of self-contained unit. Okay, so let's just check Slack. And we're good on Slack. Okay, so tomorrow we are looking at message queues. So the last two, this episode and tomorrow, they're kind of more advanced topics, but they're made so much easier with Docker. I should be pushing this button. They're made so much easier with Docker because I can just run these things in containers. So these fairly complex architectural designs, so, you know, my proxy, message queuing is all about a different way of components communicating together. Used to be a lot harder without containers, but Docker makes it super simple. So join me tomorrow, episode 20. It's the final episode, and we'll be talking about message queuing, which is much easier with Docker than it used to be without Docker. So yeah, my name's Elton. This was Learn Docker in a Month of Lunches. Hope today was useful, and I hope to see you again. Thanks.